Hello everyone, this is Parth from FTC Team 7477, and today we're going to be talking about proportional powers in driving systems. So, if you remember, this is our code from our previous video of a Mecanum drive, and this will work, but there's one part of it that can definitely be made better, and today we're going to be talking about that, and it's proportional powers. So, what that means is, if you notice in my tank video, I included a range.clip to keep the values between -1 and 1, but here I didn't do that. Now, if this goes above 1, it's just going to return 1, sorry. But the problem is that these powers, if one of them is above 1 and it's becoming like, if it's bound to -1 and 1, the the decrease won't be proportional. So if I'm looking to turn and drive a certain direction, it might not work as I wanted to, and it won't be as smooth if the powers aren't proportional. So let's actually write the code for this, and maybe that'll help to understand it a bit better and how we're going to make it proportional. So our first thing is that all these powers need to be less than 1, right? Less than or equal to 1. They can't be above 1. So the way we're going to do that is, our first step is we want to find the maximum power of all of these and divide it by that power. So for example, the say f left power is a max power, we would, if it's above 1, we would divide it by itself, which would make it to 1. But these powers would need to be reduced in the same, it's like an equation. These powers would be needed to reduce by the same amount. So we would divide this power by all 4 of these powers. So this is called scaling powers. So to do this, we're going to actually create a function, and we can name it scale powers. Okay, so it will be public. We're going to be returning an array. So it's going to be a public double array scale powers. And so our first step is to be finding the max power. And we're just going to be using the math.max function for this. So, well, actually, sorry. First, we want to put all these inputs in. So, double f left power, double f right power, double b left power, and double b right power. And we're going to take the maximum of these powers. And remember, since there's some negatives here and stuff, we want to make sure we take the absolute value of each one. So we can just, absolute value can be found by using math.abs. So just start plugging in the powers. Remember, you want to use all 4 in the same statement, so it's going to look something like that. So basically what this will do is it will find the maximum between back left and back right power, then the maximum between the f right and the maximum of whatever these are, then the maximum between these 3 powers and this one. And remember, it's the absolute, oh, sorry, I forgot to add the absolute value to that. But don't forget to add that, as that is very important, otherwise this will not work. So now this double will change into, max will be equal to the maximum value set from a motor. And we want to have an if statement that says if max is greater than 1, meaning the maximum power is greater than 1, or the absolute value of the maximum power is greater than 1, we want to divide all these powers by the maximum power. So f left power will be equal to f left power divided by max. And remember that this can be written as this. So F right power, back left power, and back right power. So let's walk through this again. Let's say my F left power is 1.5. Now I'm going to run it through the scale powers function, and it will find the maximum power being F left, and it will be greater than 1. So it's going to scale all of these down. It will divide F left by 1.5, setting it equal to 1, but it's also going to scale all these down the appropriate amount. So once we have all of this, we have all the powers, but since this is a function, we do need a way to return this to the actual program. So the way we will do this is, again, return a double array. So let's initialize that. So double array, we'll just call it motor powers equals new double array, and just the names of the powers. Right? So that's your array, and it'll have all of these scaled powers. And if there is nothing that's greater than 1, all powers will remain the same. And remember, don't forget to actually return the double array to get rid of that error in your function. And that's our scale powers function. That's going to scale our powers. And where do we want to call this? We want to call this when we have all these inputs and we have initialized these powers, right? So we are going to call scale powers and just use these powers in here. And you want to create a new double array to actually store this function's powers. Let's call it applied powers. And now we actually want to set the power to the motors. So F left, front left, dot set power, back left, dot set power, front right, dot set power, back right, dot set power. And one thing that you really need to keep in mind is you want to look at this line right here, and you're going to be using index in the applied powers for each of this, but you need to check this function here and make sure you're setting the right index to the right motor. So for example, front left power needs to be assigned to front left, and this is the 0th index. Back left is the 2nd index. Front right is the 1st index, and back right is the 3rd index. And this will set your motor power, and this will be, when you're driving, you will notice it's a lot more intuitive, as the robot will move a lot more nicely. It'll be easier to navigate it. And this is it for this video. Thank you for watching.